Circuit breakers are used in the network to switch the electrical energy on and off. Sometimes we also need to insert some physical barriers into the network so that we know the electricity cannot flow into certain parts of the system. To do this, we use electrical isolators. By the end of this section, you will know why we use isolators inside our insulated substations and appreciate all of the different types that we use. The aims of the course today are: introduce the principles behind isolators. Look at the operational aspects of isolators. Introduce the different types of isolators that we use inside our insulated substations. Circuit breakers are used to switch the electrical supply on and off in a network and are designed to break the currents that flow during normal operations and the high fault currents that are generated when a fault occurs. When the circuit breaker has done its job and stopped the electricity flowing, we may need to physically isolate sections of the substation bus bars or equipments to allow us to work on or near them, or to provide certainty that a circuit is dead. To achieve this, we use isolators. Isolators perform this feature by providing a fixed distance between live and dead bus bars, across which the electricity cannot jump under any situation. Here's a typical bus bar supported by post insulators. To provide physical isolation, we remove a section of the bus bar and insert an isolator in its place. The position of isolators is decided when the single line diagram of the substation is finalized. Isolators serve an important role by ensuring that a circuit is dead and stays dead by the introduction of the physical gap in the conductors. They can also be locked off by a padlock or isolation key by the engineers. Work permits can then be issued based on their physical position. Here is a typical symbol for an isolator. Firstly, we have a single-phase manual isolator and a motorized single-phase isolator. We then have a three-phase manual isolator and a motorized three-phase isolator. Here is a typical motorized isolator mechanism. Firstly, we have a high-torque motor to drive the isolator operating shaft. The isolator drive mechanism and conductors can be substantial and need a high-torque motor to ensure that when the contacts open and close, this is done in a firm way. Next, we have the auxiliary switches connected directly to the isolator mechanism. These provide a clear indication of when the isolator is open and closed. These are used in secondary protection and control circuits, and it's really important that they give an accurate representation of the isolator position. Next, we have the open and close relays. This allows the isolator to be open and closed remotely from the local control room and possibly from the network central control center. Finally, we have the control circuits, including interlocking circuits, to ensure that the isolator is only operated when there is no current flowing in the circuit. Isolators are designed to carry the full load current when they are closed, but are not designed to make or break load currents. This is the role of circuit breakers. Isolators are used to connect live bus bars to those that are dead, and to separate two live unloaded bus bars, so they are designed to make and break equalization currents. These tend to be in the order of 20 or 30 amps. Circuit breakers are designed to operate quickly to quench any electrical arcs. As isolators are offline devices, they can operate a lot slower, with a typical operating time from close to open and vice versa of about 5 seconds. The main role of isolators is to isolate parts of the circuit for operational and maintenance reasons. Let's look at where they are positioned in some typical circuits. Here we have a typical cable feeder circuit with a circuit breaker connected to a bus bar. When we are maintaining the cable, we want to know that there is no possibility of electricity flowing down the cable. It's therefore normal to provide a line isolator in between the circuit breaker and the cable sealing end. When this isolator and the one on the far end are both open, we know that the cable is safe to work on. Similarly, when we're maintaining the circuit breaker, we need to know that there's no possibility of electricity flowing into it from the bus bar. For this reason, we normally provide a bus bar isolator. This also provides isolation from all the other circuits when we want to work on or maintain the bus bar. Let's now look at a different circuit. Here we have a double bus bar system. Again, we have a line isolator to isolate the cable, and this time we provide a bus bar isolator for each of the bus bars. Let's see how this works on a bigger system. Here we have a substation with two bus bars, various incomers and feeders, and a bus section. As before, let's add our line isolators and our bus bar isolators. What about the bus section breaker? Again, we need to maintain this breaker, so we need to provide isolators each side so that this can be achieved. You will find that either an isolator is used all the time or not at all, depending on its position in the circuit. Both of these scenarios can cause maintenance issues. When isolators are kept closed for months on end, the contacts tend to bond together due to current continuously passing across them, and when you come to operate the isolator, it can be difficult to physically move the arm. For manual isolators, additional force can be used to prise it open. But for motorized isolators, this seizure may result in the main motor tripping. For isolators that are used all the time, this can cause wear to the contacts, especially when they are continually breaking or making magnetization currents. This may result in the contacts having to be replaced after a certain amount of operations. We use several types of isolators inside air-insulated substations. These include rotating center post. Let's operate the isolator and see how it works. Let's look at the key elements of this isolator. Firstly, we have the rotating arm, which is rated to carry the same system currents and short circuit currents as the main conductors that are connected to the isolator. As the name suggests, the arm rotates around the center post, isolating the electrical energy from the circuit. The key dimensions of the isolator are the phase-to-phase clearance, which dictates the vertical spacing between the conductors. This depends on the substation electrical clearances. Next, we have the isolation distance. This has to be greater than the phase-to-ground clearance, as one side of the isolator may be live whilst the other side is dead. In practice, you will find that the isolation distance is substantially greater than the phase-to-ground clearance, as the isolation gap is used as a point of isolation for the issuance of safety permits, and it's nice to have a bit of additional insurance to keep people safe. Supporting the arm, we have the insulators. These are very similar to the insulators used on post insulators, and will have the same creepage distance. The higher the voltage, the longer the insulator. Next we have the support structure for the isolator. This keeps the live elements of the isolator away from the ground. The key distance here is the distance from the bottom of the insulator to the ground, and the clearance distance from the live bus bar to the ground. The higher the voltage level, the higher the support structure will be. Next we have the mechanism box, which operates the isolator. As we said previously, isolators can either be manual or motorized. The next type is a scissor type isolator. We have two versions. We have a single break type and a double break type. Let's see how it operates. These are a popular alternative to rotating centre post isolators and have a similar footprint. The isolator arm rises vertically for this type of isolator, which may cause clearance issues to lines installed above the isolator for multi-level substations. The next type is the double end break isolator. Let's operate the isolator to see how it works. These can be slightly less expensive than the previous two isolators, as we only need 2 post insulators per phase. The main issue with this type of isolator is that the isolator arms extend sideways, which may cause clearance issues with equipment positioned in adjacent bays. The final type is the pantograph isolator. Let's operate the isolator to see how it works. These isolators are designed to be positioned directly below bus bars, which can significantly reduce the length of the equipment bay. These tend to be used on extra high voltage circuits, when reducing the spacing of the equipment can significantly reduce the overall substation size. The mechanisms for these isolators can be quite complex, as ensuring that the contacts at the top of the arms make a good electrical connection can be difficult to achieve as the isolator ages, and they may need to be maintained more often. Isolators come in all shapes and sizes, and the substation designer needs to pick the type required based on the configuration of the substation and the land available to build it on. The most common type used in air-insulated substations is the centre post isolator due to its simplicity and low cost. Pantograph isolators are the most recent type to be introduced. These allow isolators to be placed directly under the bus bars, which reduces the overall size of the substation, and tend to be used on high voltage substations. Let's summarise what we've learned today. Isolators are off-load devices that provide a physical break in the electrical conductors. This gives confirmation that a section of the circuit is dead. Isolators can either be manually operated or motorized. There are many different types of isolators, including rotating centre post, scissor type, double end break, and pantograph. The decision on which isolator to use depends on the substation configuration. Congratulations for completing this section. You should now understand why we use isolators inside air-insulated substations, and appreciate all of the different types of isolators that you will come across. I have attached some questions on today's section to test your knowledge.